Okay, in the last video, we started looking at this particular differential equation. We talked about the fact that the solution was of the form y is sum from n equals 0 to infinity of a constant times x to the n. We also discovered that the derivative and the second derivative can be written in these ways. And I've already gotten started a little bit. I actually plugged those series in for y, y prime, and y double prime. So here's y, y prime, and y double prime. X squared plus 1 times y double prime plus x times y prime minus y. Okay, so what I want to do now is try and combine these three series into a single series so that I can then hopefully solve for my constants. So before we get really started, we have to deal with this fact that we have a polynomial times a series. And so we're actually going to have to distribute. We're going to have x squared times this whole thing and 1 times this whole thing. So let's just go ahead and write that down. X squared times the sum from 2 to infinity of cn times n minus 1 x to the n minus 2 plus 1 times the same series plus x times our y prime Okay, next up we want to combine or distribute the x squared into this series. So x squared times the series, x squared times the sum is actually going to be x squared times x to the n minus 2 because we're actually distributing x squared times each part of the series or each term of the series. So x squared times this is going to end up being x to the 2 times x to the n minus 2, which would be x to the n. So cn times n minus 1 x to the n plus sum n equals 2 to infinity cn n minus 1 x to the n minus 2. Didn't really have to change that one since it's just being multiplied by 1. This one is being multiplied by x, so it's going to be the same thing as over here. X to the 1 times x to the n minus 1 would end up being x to the n. And finally, cn times x to the n. Okay, so our next step is to combine four series into a single series. We talked about this before. There's going to be two steps still to go, which is let k be the exponent, so they all will have the same exponent, x to the k, and then we'll have to fiddle with the starting points. But our first step is going to be k being the exponents. Okay, so k equals n. For these three, we're just going to recopy them only using the letter k instead of the letter n. The one in the middle is the one that's actually going to experience some changes. If we add 2 to both sides, n is equal to k plus 2. And when n is equal to 2, k is going to be 2 minus 2, which is a 0. So just looking at our bottom part of the summation, which is our starting point of the summation, and relationship between k and n, we're going to have a series that starts at k equals 0. And Cn, in this case, is going to be ck plus 2. N is k plus 2. N also k plus 2. N minus 1 is 1 smaller than k plus 2, so k plus 1. And x to the n minus 2 was our x to the k. That's what we want. We want all of them to have x to the k. Okay, so then I'm just going to recopy all the other ones. Okay, and finally, we need to make them all start at the same place. And we talked about this before. The way we're going to do this is we look at our starting places 2, 0, 1, and 0. 2 is the largest of those, so that's the one that's most fixed in place. We're going to have to leave that one as it is. We'll have to change these other three so that all of them also start at 2. So I'm going to just recopy this one down. Okay, so we have a series that starts at k equals 0, and when k is equal to 0, we have c 0 plus 2 times 0 plus 2 times 0 plus 1 times x to the 0. When k is equal to 1, we have c 1 plus 2 times 1 plus 2 times 1 plus 1 times x to the 1. And then everything else is going to be part of a sum where k is 2 and onwards. Okay, I'm now going to pause the video and I'm going to do the same thing for these two. I highly suggest that you also pause the video and try and do the same thing. We're going to try and split this up as a k equals 1 and then k bigger than 1, a k equals 0, a k equals 1, and then a k bigger than 1. So pause the video yourself and see if you can figure that out. Okay, if you were able to successfully do it, then I'm really impressed because I actually made a mistake before I told you to pause and before I paused my end. This part right here where k is 2 to infinity, I should have said k is greater than or equal to 2 in this case. So I made a mistake, which might have made that challenge a little bit trickier than it needed to be. If you do actually do that, this is what you should end up with. So our third series is this third thing in brackets. So all this is just one gigantic line. First series, second series in brackets, third series in brackets, and then minus the fourth series. Okay. I'm actually going to pause the video one more time, and what I'm going to do is I'm going to shuffle the order. I'm going to put my x to the 0 terms first. I'm going to put my x to the 1 terms next. And then I'm going to put all of my series one after the other. They all have a series starting at 2. They all have an x to the k as their exponent. So I'm going to pause and just shuffle the order of all these terms. Okay. I slid the page up a little bit and then I did the reordering that I was talking about. So the two things that are underlined are the c2 times x to the 0, which I'm just going to call 2c2, a minus c0 times x to the 0, which is just a minus c0. We have c3 times 2 times x, which is 6 times c3 times x. We have a c1 times 1 times x, c1 times x. We have a minus c1 times x minus c1x. And then the four summations, I just wrote one after another. Okay, and so the last step to combine the series is to just, since they all start at k equals 2, we can essentially factor out the summation symbol and have summation k equals 2 to infinity of all the insides, and then also all of them have x to the k in common. So I'm going to do both of those steps at the same time and just show you what it looks like. I can also do one other thing. C1x and negative C1x are actually going to cancel, and so we really just have 6c3 times x. So our constant term, the part without any x's, is a 2c2 minus c0. Our x term is 6c3 times an x. And then plus our summation, everything else goes from 2 to infinity. We have this coefficient multiplied by x to the k. We have this coefficient in here multiplied by x to the k. We have ck times k multiplied by x to the k, and we have a ck multiplied by x to the k. So we've successfully combined all of our series into a single big series with some initial parts to it.